On the AP chemistry test, there is usually, if they talk about a redox reaction, there's usually a picture of a battery. And these batteries can be very, very different. We have taken these galvanic or voltaic cells with the liquids and we've made them a little bit more high tech. The principles of how these batteries work is still the same. You're still going to have an anode and a cathode. The electrons are always going to flow from the anode to the cathode. You're going to have metals involved. You will have a redox reaction with an oxidation step and a reduction step. In this goal, we are going to just look a little bit about some different batteries, just so you can see some of the differences that you might see on the AP test. So a battery is a self-contained electrochemical power source, and it contains one or more voltaic cells. This is where the technology has come in, and we've had batteries for over 200 years, and especially with our technology age in the last few years with all our cell phones, a lot of research has been poured into making batteries, making them safer, making them last longer, making them recharge more. This first picture just shows an alkaline battery. So these are the most common non-rechargeable batteries. The anode is powdered zinc in a gel, and it's in contact with a concentrated solution of potassium hydroxide. You do have some sort of separation that you have to have because you need to have those ions in the salt bridge be able to travel, and you also need to have your electrons travel somehow. When batteries are connected in a series, the total cell potential, or EMF, is the sum of the individual cell potentials. Here is a picture of a flashlight that has two batteries in it. So each battery can provide 1.5 volts. If we put them together in a series here, we can actually get 3 volts. 1.5 volts might not be enough to power this light bulb, but if we put them in a series, then we would get enough volts to turn on that light bulb. A lead acid battery is found in your car. That's a typical car battery. If it's just a normal combustion engine car, they usually use this lead acid battery. And it's a 12 volt battery, and it consists of voltaic cells, and each of them produce 2 volts. So that's why it's 12 volts, because there's be 6 of these voltaic cells, and so if you add those up, you get 12 volts. You actually can calculate this with our cell potential sheet to figure out how many volts that there are as far as the chemical reaction goes. Here's a picture of this 12 volt battery down here, and you can see that again you have an anode and a cathode, electrons going from the anode to the cathode. As far as on the AP test identifying where the positive and negative electrode are, that is beyond the scope of this test, but you should be able to know which one is the anode. And I can tell right away which one is the anode in this picture, not because the anode is on the left, but because, and it's pretty tiny, it says the electrons are flowing away from this one. So, and I always know it goes from anode to cathode, and it goes in alphabetical order, A to C, or it goes oxidation to reduction, O to R. The electron flow always goes that way. But again, we see some sort of separation here. The salt bridge, those ions are able to travel through that liquid from each of the electrodes. A typical rechargeable battery is a nickel cadmium or a nickel metal hydrate battery. These might be the little green rechargeable batteries that you can buy at the store. You have a discharge system and then a recharge system. One of them requires no energy to be put in, so it is thermodynamically favorable, and so that pathway is shown down here. This would be the anode, and it's discharging, so those electrons are coming this way. This little I, that is current. Current is identified as the positive flow, and so it always goes opposite of the electrons. So current's a little bit weird in that way, and it's on this diagram, so I just wanted to point it out. But if you'll just be concerned about the electron flow, that is typically all the AP board is going to talk about. But as far as the discharge goes, it goes from anode to our cathode, and we have, as those electrons go, we do have a very complicated ion system here that is flowing back and forth, and there's some sort of electrolyte gel or more of a solid material that these ions can flow through. Now, to go backwards, to recharge this battery, we need to run everything backwards. And so you will plug this into a charger, and this will change what the anode and the cathode are. After I plug it into the wall, then this side becomes the anode. It is going to pull the electrons over this direction to recharge the battery, to make everything go back. And then our ions flowing through that electrolyte paste, they will do their thing in this area. That's a little bit how rechargeable batteries work. This is a solid state lithium battery, and we usually have some sort of lithium battery in our cell phones. So we have some lithium metal here. Lithium has some good things going for it. It has quite a high electrical cell potential as far as its half cell goes, and it's very, very lightweight. However, when lithium comes in contact with water, it is very explosive. And so this is a non-aqueous electrolyte, some sort of thing that the ion can travel through. We have our anode, electrons being shuttled from the anode over here to the cathode. And the cathode, this is a cobalt type material here. But again, we still have some sort of ion moving here. In this case, it's the lithium ion that's moving. Occasionally, you might see a fuel cell on the AP test. They have had them before. And a fuel cell is an electrochemical cell that requires a continuous supply of reactants to keep functioning. And typically, there's some gases involved, or it needs to be open to the atmosphere to get oxygen. Here is just a sample of a fuel cell. So we have our anode, and notice the hydrogen gas there. And then our cathode, notice the oxygen gas there. And so this will keep going as long as we have a supply of hydrogen and a supply of oxygen. As far as the principles of how this battery works, everything is the same. Our electrons are always going to flow from the anode to the cathode. We are always going to oxidize at the anode, and we're always going to reduce at the cathode. Here you can see on the half equations that we are losing electrons here at the anode, and then we are gaining the electrons here at the cathode. We can balance those. Those electrons will cancel, and I can bring everything down to have my overall reaction. But the thing that is unique about this is it only keeps flowing as long as you have those reactants. And because they're gases, it needs to be hooked up to a gaseous supply.